welcome back to the channel. It's Mark from PowerSonic and Apprentice 121. Today we're going to look at some RA testing, so some earth electrode testing, and this is going to be part of a wider series covering different types of electrodes or discs, and also the different ways we can measure them for their impedance to earth. So around, and we'll show you what I've got set up with the TIS MFT Pro Plus, because this does earth electrode testing. If you get the kit, it comes with all of the probes and the leads that you're going to need, and I'll take you through how I've got it set up now. Just to say from the beginning, so this H probe, that's your current probe if you like, so this is this blue wire here that goes off to the furthest point, and then your voltage probe is this S1, which you want the midpoint between the final current probe and the earth electrode under test itself. But we'll have a look at all of that. So you can see the black and the green here, these are just combined and they go to the electrode itself. As I'll show in a little bit, the whole of this install is isolated, but essentially we've got a little consumer unit in the corner of the shed there. That's turned off, everything in here is off, and there's a little rod just down the side that we're testing here first, and that is just straight into soil. So that's what we've got set up there. And then if we follow these blue and red leads, so the voltage and the current spike, you'll see the voltage one. I'll just zoom out a little bit wider. How am I going to do that? There we go. And you'll see here we're onto this little spike in the ground there, and there is another spike just there ready to go as we move backwards and forward to get some other measurements in a minute. And then over the little fence through into this little play area that the kids have, you'll see down here we have this other spike as well on the current clamp, and that's the shed there, and the electrode is just the other side of there, so we're kind of in the middle. And then out here, everything we've got under test. It's important when you're doing your electrode testing that you make sure you get your distances right, so you need to be going 10 times the distance of the rod under test, and ensuring that your voltage spike is in the middle of that, and then you move around back towards the electrode and then out towards the current spike to try and make sure you're going to average out to what is a reliable reading. And I'll take you through that on this little video here. It's really important that you don't move the voltage spike in and amongst your earth electrodes, because shed here I've got a few electrode systems in place already, and if you was to have them all connected together as I usually do, it's not how it's set up at the minute, it is just going off that one electrode. You know, you can get readings that aren't accurate because you're moving your voltage spike amongst essentially what is your earth farm. You must make sure you're at the midpoint between the current spike and the electrode under test. What here is my main intake is down the side of the house there, and we are a TNCS PME supply, so we can have a look how our earth electrode just into the soil in this case might overlap with some of the buried services in my garden and the supplier's earthing system itself, to see if we do have the isolation that would maybe be needed in terms of being disconnected from the earthing system to these properties when we pop in an electrode in. In a rule of thumb, they say to get 10 metres away from any buried services, and I know in this garden it's near on impossible because the gas services run through the back of the houses, the water services run through the front. They're all metallic. This house was built in 2001, they aren't plastic services, and I can show you that as well in a little bit of this video. I'll get that on camera. So yeah, there's lots of stuff buried here that is all bonded back to earth, not just in my property but in the ones next door as well. So even if I'm to disconnect the main earth coming in off the supply at the house itself, you know, I'm still going to have those crossed connections and parallel paths due to the bonding in place in neighbouring property. But we'll cover that in a little bit on the video. I am going to record this at varying points. We're just going to focus on the earth electrode in the soil for now. Other videos are going to look at a conjure disc and an earth electrode in bentonite, varying lengths of earth electrodes as well. So we're going to have a massive play around with all of this and build it out in the coming months. I'm not just going to drop them all together because I realise electrode testing is not the most exciting subject, but it is something people are going to be doing much more of, especially with a change in regs coming with Amendment 2 and the suggestion of these parallel earth electrodes needed on TNCS supplies, you know, and how we're going to test and verify the impedance of those, if we're just going to do it under the live condition method or if we're going to go to the trouble of using RA to get our values. And hopefully this video will explain what some of the differences might be in the values you obtain based on the selection and measurement you take, because we're going to do some ZE tests in a traditional way as well under live conditions that you'll all be familiar with, I'm sure. So yeah, it's just one of those where we'll cover a bit of the RA testing. It's new to a lot of people. It's not something lots of electricians have much experience with. I thought it might be interesting. There is some content on YouTube already. John Ward's done an excellent video on it. There is also some very shaky content on electrode testing, so choose your sources wisely. With me, Cooper. He's here to press the buttons. Not really Cooper, but if we hit test, and you'll see here actually, if I just take you through the TIS itself, if you go into settings, you can choose if you're on a TN or a TT system. It doesn't really change the way in which the test's done, but it presents the result in a different way, and I'll show you that later on in this video just as an example. But for now, we'll leave it on TT. I know this isn't a TT install, before people get upset with me about that. It is just an earth electrode on a TNCS system, but people often just refer to it as TT. If I hit the test button, it's now going to carry out its little magic calculation between the current spike, the voltage spike, and the actual clamps onto the electrode itself. It will actually give us a resistance value here to that current spike, to the voltage spike, and then an average of the electrode resistance for RA. So it's actually given us some extra information with the TIS MFT Pro Plus that some other multifunction test instruments don't give you. And yeah, it's insightful just to see the value of impedance to those prongs themselves. So you can see here we've got 85.6 ohms. It's given us a thumbs up because it's assuming on TT we've got this 30 milliamp RCD protection. You can change that if it's different. And yeah, this can also do the clamp test, and I'm going to cover that on a video. I have spoken to Steve from TIS about getting one of those on order, because I want to show how this works. It is a bit of a nifty piece of kit that. I think it works wirelessly from the instrument in the way it'll store its results and then backfeed them in later as well, so we can have a massive play around with that when it arrives. And also you can do your 4-prong tests, so you don't need to use an electrode itself. You can just check the resistivity of the earth by going off and putting your probes in the ground and carrying out some tests, and you can set the distances between those in this little scale here. So yeah, pretty useful instrument. And there is a specific way of setting this up to do your resistance measurements between the main earthing terminal to a house, for example, and an earth electrode, to see if you've got any overlaps in perhaps where they might be crossing over in the mass of earth. So when you think you have got a detached earth electrode, you actually don't. You are still connected essentially through the mass of earth itself and buried services within it. Yeah, I'm going to go and move that voltage spike now. I'll take you with me to do it. We'll just shift it a little bit towards the earth electrode itself. I'll try and get this in a one hit if we can. I've set the spikes up. Kids have had a right old play out last night. You might see them later on in this video as well, because they helped me get a few different readings. It's a wet morning today, it's been raining, so I thought this would spice the video up a little bit so we can show some of this testing in dry, hot conditions. When I did it during the little mini heat wave we had a week or two ago, and then these wet rainy conditions I've had this morning, and a bit of something in between with the kids last night, and I'll just clip all that together as best I can following on from this. So you can see now we've just moved a little bit nearer on the RS probe, and you can see the values here have adjusted because of that, but the main RA value is sort of consistent. It's a little bit lower, but you know, generally it's there or thereabouts at 85 ohms. Now I'm going to shift it a bit nearer to the final prong, so the current spike. And we'll have to do this by going through the gate. Hopefully it's long enough. I might have to go and unwind a bit more. We'll see. Yep, let's go and unwind a bit more of the old and red. Should have had that covered, Cooper. Should have unwound a bit more, mate. So I'll just have to pop you down a sec while I do this, and I'll jump back on and take you out to that other spike. Okay, so Cooper's worked his magic. You can see he's flat out down there, and we've got a bit of extra slack now on this voltage lead, so I can slip through the gate and clamp on just down here. See, we're on there now, so we've moved a little bit nearer the current spike. you want to know what's going on now? Probably thinks he's off for a walk. If we hit test again, and we should see a little variation of the RS and RH values, and then the RA will be there or thereabouts, I expect. I'm not expecting this to change drastically, but you never know. And then obviously record a few results, move that, so it's gone a little bit higher. You can see there has been some adjustment there. So you will have to repeat that process. I'm not going to show it all on camera, just moving that voltage spike around, and then take an average mean value on your measurements based on what you found. And as I said, I'm going to show this being done on a hot sunny day, and also on a bit of a intermediate day, and then, like it is today, a wet morning. And in the future videos we'll repeat it on the different electrodes, and we'll pull all the maths together right at the end once I've gathered all of the results. So we're not going to delve into that today, we're just going to go through the process of getting those RA measurements. And yeah, let's move this video on. So I've got the gear all set up here. Obviously I need to get the leads out across the garden and out around the back. So this is the CU down at the garage. I'll show you what we've got at the supply end as well. But essentially we've just got MCBs down here. This is going to our earth electrode, which is just outside the back of the shed. I'll show you that in a sec. Obviously all the load down here is now switched off, so we've got nothing coming down here. So I've prepped the electrode lid, so that's all off. You can see we're down there, and we can get a little clip onto that, set the TIS tester up, and then get some RA measurements across the garden. So yeah, we've got all the gear set up, and I can show you exactly what we're going to do to tackle this. We can drop the wires out across the garden now. It's a 1.2 metre long rod, so obviously with that you need to be going at least 10 times further between your spacings of the probes, but we'll cover all that as the video moves along. Note with the TIS tester, if you're not familiar with this one, it does give you a help menu. So you can see we've got the 3-wire earth testing for when you're doing your RA measurement. This will be the one that most people are familiar with. So you obviously go onto your earth rod and then take your spikes out, and this is the distances that we're on about. So we've got a 1.2 metre rod, we need 12 metres, and maybe go a bit further and have a play around with this. And then you just move the prong in the middle around 10% in either direction, see how it affects the findings. This also does the 4-prong test, so you don't actually need an earth electrode itself. You can use the 4 prongs in the kit, which I'll show you, and just get an indication of ground restivity. And you can also use the clamp meter as well, so you don't need to disconnect the earthing system to get your measurements. But we'll see as much as we can in the video and cover as best I can the full range of tests this thing can do. And yeah, let's get on with it. So we can see in the board there we've got the main switch with the SPD, and down the end here we've got this double pole RCD which leads off out to the shed. We've also got an MCB there that looks after it as well. Not gone for the RCB on the Hager because it is just single pole and a solid neutral, and we wanted the RCD to open both poles because we are down on an earth electrode at the shed. So just made more sense for us to set it up like this. Obviously this isn't how you would perhaps tackle it on your installs, but works a treat here. And we can turn the power off to the shed pretty easily. So now we know down there, obviously with these locked off, that there can be no possibility of the circuits getting energized while we do our earth electrode tests. Okay, so this is a different day, and the reason being I lost the footage. So yeah, brilliant. I've recruited Jack and Isabel there. They have helped me probe this out, so they've helped pick the spikes back in, disappeared over the fence somewhere. Maybe you never see him again, you never know. We've got the test set rigged back up, and as I showed you on the other video, we have got the blue going out to the furthest spike, the green and black both going to the electrode itself, and then the red is the midpoint, which you can see I've got on that spike over there. So if we hit the test, and you will see it's having a good old think. You might be able to hear it clicking away there, doing its stuff. So this is something it doesn't rush at, none of the test sets do. You can see it's given me a fail because I've got this set for as if it was a 32 amp circuit, which it isn't. And you can see here we've got 82.9 ohms on the RA, and you can see your RS and RH values there as well. So got 0.2k and 0.3k. So that's those ones. If I am to play around with this, and if we was imagining this was a TT, for example, with a 100 amp head as a typical example, and we want to be on 0.4, this is just to demonstrate the different calculation that the test set actually makes for you when you're processing the test. And you can see here I've actually got it set in the TN mode, so we'll adjust this as well. So again, it's having a good old think, measured a similar value, and it's given us another thumbs down because it thinks we are on a TN system. So if I go into the settings and I change this over to TT, make sure everything else is set correctly, and we go back, into the right test, earth resistance, and you can see here it thinks we've got 30 milliamp RCD protection. If we hit the test now, it'll run through the same process, but it will display the result in a different way. Well, I hope. So for those of you who are eagle-eyed, you'll be able to see the time and date on this video as well. So this is a different time and date to how I filmed the other one. So we'll take another measurement of our live ZE as well, or ZDB, just to compare today. But that's what we're getting here. I'm going to move that prong a little bit nearer now. I'm going to do that because I think the hooligans sound like they're up to something as well. Don't know quite what they're doing out there. If we take this one and move it a little bit this way, so you can see we've got on a different electrode. Well, ground spike. So we've moved a little bit closer to the electrode with that one. And it is a process of moving a little bit nearer and a little bit further away on that midpoint probe. So we move a little bit closer towards the electrode, and then we'd move a little bit closer towards our furthest test lead, if you like, and just see how the value varies. So you can see it's increased a little bit there for our RA. So I'll move it the other direction and we'll see how that looks. Just gone a little bit further away on the red probe. See, I've just moved that over there. And we'll see how that affects things. So we've gone a little bit closer towards the furthest ground spike. So we're a little bit further away from the electrode itself, and you can see the values varying ever so slightly. But it's given an acceptable value for RA. If we were a TT electrode, we're under 100 ohms, which is what the NIC used to issue as guidance for kind of what you would want to accept as your maximum value, and it's obviously well underneath the 200 ohms that the regulations dictate. There's another interesting test we can do here, and that's to see the resistance between the main earth in the house and our electrode here, and see what potential kind of overlap we might have in the way they conduct due to buried services within my garden. Okay, so you can see here these are my meter cabinets. That's got the TNS PME supply in. This has got obviously the gas pipes and also the bond going on there. So essentially I've just joined to this copper gas pipe. Easiest place to bond onto really. So that's the current and voltage spikes. If you want to measure in this way, I'll pop a little picture up somewhere in the corner of this screen. This is how you do it with the TIS MFT Pro Plus. You take your voltage and current spikes or connecting points, take them and connect them to the main earthing terminal. Can, if you want, obviously disconnect that if you just want to measure the actual main earth terminal coming in, but as I've said, due to all of the bonds and the neighbouring properties, and I know this because I've repeated the test off camera, it's pointless. You might as well just connect it all onto the system as a whole, and then you're going to pick up all those parallel paths through the mass of earth and get some sort of idea of what kind of overlap you might have in the ground due to buried services and other such things on the earth electrode you're putting in someone's garden for a hot tub or an EV charge point, or even these parallel earth electrodes that people now need to be installing. So we'll go and hit the test button. I'll show how it's set up down the shed as well. Let's have a wander. Might as well follow these blue and red leads. I'm sure Cooper's on it. He's waiting to go in. So the black and the greens, again, as you'll have seen on that picture, are still going off to the earth electrode, and we can hit test. I'll leave it on the TT setting, it still carries out the test in the same way. I will demo what it shows you as a result if you do change it to TN, just to show how it highlights an issue if you're selecting that as your supply arrangement. So you can see here the RS and the R1 are showing at 2 and 1 ohms. So that's interesting. That's much lower than when we had the spikes out in the ground. And also we've got this as our impedance value of the electrode itself. And as I said, we'll explain how all of these maths pull together in a future video. But that is actually demonstrating to you quite clearly that there is an overlap between the buried services in the ground and also your earth electrode under test. And this is a unique feature on the TIS MFT Pro that lots of the other multifunction test instruments certainly don't include. So that's the key insight, the resistance values to RS, RH, or otherwise known as the voltage and current spikes in your volumetric measurements, or whatever they refer to it in the regulations. It's giving you a bit of insight there as to what those values might be. And yeah, there is a path, a connection, and as I explained when we were looking in on the garden, the gas, they're unusual. These are like block and beam, I think they call it, so the gas actually comes up inside the property out of the ground. But the gas route, because of the little pits that they have at varying points along these back gardens, run along the rear of the houses, the water pipes run along the front, so it's kind of surrounded in a way in what might be referred to as an earthing grid, if you like, fortuitously, because of the way the services are brought into these premises. And I would have assumed they would have been plastic, but for whatever reason they are not. So it's an unusual one for a property of this age. It was built sort of between, I think they started building them in '95 and finished it in 2001. So maybe there was some sort of crossover in what they should have been doing, I don't know. But yeah, that's affecting the values of any electrodes. And even on the 10-meter distance where our electrode is to where the main earthing terminal is not 10 meters. It's very difficult in this garden to get 10 meters away from that in any case, because next doors is just here and the other side is on the other side of the house over there as well. So it's even more tricky in other urban areas where you've got terraced housing and back to back, and you could even have rows of houses supplied off different transformers but sharing water bonds. It gets really, really complicated. So if you're trying to rely on an electrode to give you separation as your earthing system on a particular piece of equipment, you're maybe not getting the separation you think just by putting an electrode in the ground. And when you're trying to comply with the requirements of 702, as I've said a few times, it's really important that you actually do that if you're not going to go to the trouble of installing an earth nest or some sort of earth grid to equalise the potential around the equipment in use, rather than just supplying it from an electrode that essentially has a connection back to the PME earthing system anyway. So let's move on with these videos and get some more measurements, and we'll come to some sort of conclusion at the end. Okay, so we can have a little look at a ZE measurement using the live testing measurement. I'm calling it ZE. We know it's a ZdB measurement in truth, and also that this is earth electrode testing on this particular shed. It is not a TT system, this is a TN system to the property. We've just popped an earth electrode on this outbuilding, and we didn't have to do that as well. I'll speak about that later on. But if I spin you around, you can see we've got the power on down here now. Just pop the socket circuit on, literally less than a meter's worth of cable down to that socket. It is a radial circuit, so that's not going to impact on anything. If I just pop the TIS test set up, you can see we're measuring between live, neutral and protective earth. I've got it on no tricks. Obviously we've got the RCD inside. If I hit test, it'll run through its little test sequence and it'll give us a value of ZdB for down here, because I know some people are a bit anal on their terminology, so we'll try and refer to it in the right way. And you can see we've got 61.4 ohms. So this is me going through the ZE measurement, and I've just, again, to this socket. Actually, we'll just unplug that Wi-Fi router. Last thing on the circuit. And if we hit test, actually you can see the date and time there again, so you know I'm not making this up. And Isabel's roller skating behind us. We'll just see what value it's going to give us today. And then we can have a little chat about all of those different values. So it reckons we have got 64.7 ohms on the electrode itself today. Okay, so we're going to get a last bit of value from Guidance Note 3 Blue Edition. Obviously when this drops as a video release, we'll all be on the brown book by then. But I just thought we'd have a quick look through this one, and you can see here this is chapter 2, GM3, and it's talking about earth electrode testing and how there's the 3 methods So you've basically got your earth electrode tester, which is the fall of potential for your 3 and 4 terminal types. And you can also do the stakeless or probe type measurement, and then you've got your earth fault loop impedance test, and I've shown that on this video as well. It explains about test method E1, which is the measurement down here, where you can see you've got your 2 probes out into the mass of earth and then your earth electrode. And as we said before, as it says up here, you need to be 10 times the maximum dimension of the electrode system. So if you've got a 3 meter long rod, 30 meter distance between your spikes. But as I said on mine, we've got 1.2 meter rod, so those distances drop. It then goes on to talk to you about the measurements that you take, moving the T2, which is the middle spike, about by 10%, as we said. And that's to sort of try and give a variation in the measurements. And it says here, compare the 3 readings, a percentage deviation can be determined. This is calculated by taking the average of the 3 readings, finding the maximum deviation of the readings from this average and expressing this as a percentage. So that's one of the critical things you do need to do. And the accuracy of the measurement using this technique is typically 1.2 times the percentage deviation of the readings. So it's really difficult to get better than 2%, and it's inadvisable to accept readings that differ by more than 5%. So if you're getting huge variation, then the test you've done is probably of little value. So you need to look at how you've done it and see if you can adjust the way you're carrying out that test. Otherwise, use a different method to get a more accurate reading, I guess, is what this is sort of suggesting. And yeah, just goes on to explain how you do that. We've kind of covered it in the video, but it's there in the book if anyone wants to go off and read it. You've also got the coil where you can use a clamp meter. So if you can't disconnect the earthing system, and that's another point to note actually that they reference here, that if you are working on the electrode and need to disconnect it, make sure it's not providing a means of earth for any other part of the install. So I was lucky down at the shed, there's nothing else that uses that, so I can crack on without having to turn the entire install off. But if that's not the case for you, make sure you are considering that. But yeah, you can put the clamp around the earth and use your spikes out into the mass of earth and get your test measurements as well. Also do a similar thing with your 4-stake system. So this is all detailed in here, and then getting your average reading for the value of your RA, and then you can do a simple loop impedance test as I demonstrated on this video as well. So it's all in there, all in guidance note 3, which is a handy little book. And said, doesn't matter that we've been showing that on this video because it's kind of obsolete from Monday. We've got a new version, the brown book. It's all going to have been rewritten and shuffled about and changed a bit, so we'll have a look at that when it drops as well. But yeah. I just thought I'll quickly jump on while I'm out waiting for Isabel at her dance class and discuss some of the findings of these earth electrode measurements. And I'm going to build on this. Like I said, we've got other earthing systems in there that we're going to mess about with as well, but some really useful information I think to take from this video. Certainly that's the way I'm looking at it at a personal level. Hopefully people watching are going to get something from it as well. But yeah, just looking at the differences that we've got with our RA, the live ZE measurement on the earth electrode itself, and then also looking at some of the resistances between the earth electrode and the main earthing terminal on my house. And it kind of makes you think a little bit about hot tubs. That's one of the reasons I'm doing this. It's to look at the different earthing solutions we've got, and also a bit of forward thinking to what might be coming at the side of my little shed in the future. Yeah, as these videos move along, there are plans in place to do some interesting things. But if you actually look at the way earth electrodes can overlap with PME supplies in the ground, and some of the guidance sort of leans on that 10-meter separation between the earth electrode and those buried surfaces and other metallic things in the mass of earth, it's really difficult in urban areas to get that. And in my particular install, my garden, it is impossible to put an earth electrode that is 10 meters away from any of that. It's not possible. And that's the same down my street and in most of the town where I live, and probably I would say for a good 80–90% of urban area installations. So in simply putting a hot tub on an earth electrode, big no-no for me. That doesn't achieve the compliance we're looking for those who wish to put upon a hot tub installations as being part of section 701 or 702. You You know, it's just not a reality. And the game with the TNS supplies, where people will say, well, it's a TNS, we'll just use that. We know now from what the DNOs are saying that we are not to assume, just because of what our main intake looks like, that it is TNS. The assumption should be that it is TNCS. You often see those debates cropping up on social media, and there's validity in them as well. We know the network repairs that get carried out don't reinstate TNS. So yeah, that's a tricky one for us to overcome. And yeah, it's just to put that out there, that if you just think popping along to a job where you've got a hot tub to connect up onto a TNCS PME, and you don't want all the hassle and aggravation because of the stuff you've seen on social media, simply driving an earth electrode in the ground does not achieve compliance with section 702 in lots and lots of applications. That's just the reality of working out on the coalface as an electrician. And I've demonstrated it here on my install. I've demonstrated it on another 2 hot tub videos on my channel actually as well. We approach it in different ways. We use earth electrodes. Point of note, that doesn't make your main earthing system a TT. People refer to it as TT the hot tub, and we know what it means by saying that, but it is an earth electrode on the hot tub. The wider earthing system remains in place, and that's a vital point of note, because you will have those PME supplies running in the mass of earth around your earth electrode. That's why I keep emphasising it. But yeah, not wanting to take this video off course away from the measurements of RA, and also the measurements of live ZE on a earth electrode. And again, I'm calling it ZE. I know, as I've mentioned at the start of the video, it is ZDB. Yeah, just interesting. Let me know in the comments what you think. If you've got any points that you want me to consider, if I've made a cock up in some of my assumptions on this, or you want me to look at a particular aspect on future videos, let me know. I am here for the discussion as always. Thank you very much for everyone who's stuck with this one and watched it, and I will keep the content coming. There's lots on the way. Thank you for watching.